Okay, everyone, I'm going to start today's lecture. So first of all, do you have any questions from anything that I taught you last session or before that? Any questions? Okay, so two things. The first one, I posted on BBLearn and sent two announcements about this. In case you missed that, I posted a makeup quiz for your quiz 3. So if you don't see your grade on BBLearn, the reason is that I don't have your solutions. If you believe that you send me your solutions, just come talk with me or like send me an email. It's possible that it happened to some of your friends that they emailed me their solutions beforehand and I couldn't find it. So, or if you think that you know the materials, you are also welcome to come to my office and then just walk me through the solutions and explain to me how you solve the quiz. Other than that, if you don't see your grade, I didn't include that because I didn't have your solutions. And based on quiz 3 and your exam 3, I wrote another quiz which is basically the same. I just changed some numbers or like some chemical formulas. So if you didn't give me your solution, this quiz would take you just less than an hour. Any question about that? And the due date is on this Friday. I posted the quiz on Thursday. Question?
Yeah, not on that, but a general question. If we email you, will you give us a breakdown of what our grade is currently in this class?
Yes, I wanted to do that during the weekend, but it was like more work. So I'm going to upload that on BBLearn. So not your overall grade, but like your exam 3 grade and also the exam that I substituted that, so the updated grade, so you can easily calculate that.
But if we like email you, will you give us like exam 1 too?
Yes, of course, yeah. Yes?
So when you say upload homework on BBLearn, is that past homework questions as well?
So the first homework question that I gave you, I didn't generate BBLearn because I wasn't sure how many people are going to respond to me. So I told you the first one to email me, but from now on, I generated just folders for you to upload your homework. So I appreciate if you can upload on BBLearn. And if you have any difficulty, just email me. I teach you, I'll show you how to upload them. But this is much easier because I can just go to BBLearn. I see that you submitted your homework and I can easily grade it. And I make sure that I won't lose any homework. So, I mean, it would be in my emails, but sometimes, you have to email me and say, oh, I don't see the grade for like my homework, So it's much easier for me if you can upload it on BBLearn. Any other questions? And the due date for the homeworks are the beginning of the next class, but if you have any difficulty, just email me and I give you extension. But I appreciate if you do that, because if you don't, I cannot distinguish if you wanted to do the homework or not, if that makes sense. Okay, any questions about these, your quiz, your homeworks? Yes? What about the textbook? Sorry, I didn't hear.
Textbook quizzes we get before exam 3.
I didn't understand the question. So,
He's
what?
asking about the 5 extra credit points from the.
Yes, sorry, I wasn't hearing well. So, those ones, I have all of your screenshots, so I'm going to just add them. So, it took me more time because I think, at the time I didn't generate the BB Learn homework assignment folder, so it just takes me more time because about like 170 of you submitted those, so it just like takes time for me to add them. But don't worry about that, I'll add them. Yeah, thank you. Yeah, sorry about like not hearing. With the masks, that's why I'm trying to shout so you understand what I'm saying. So anyway, any other questions? Okay. So if no more questions, I'm going to continue with chapter 8. And to save me some time, I wrote these before the class, so I don't have to just write everything, and I have more time to explain the materials for you. So we talked about chapter 8, which is quantities in chemical reactions. And one concept that we talked about a lot, but I didn't specifically point it out to you, is like stoichiometry. So in chemical reactions, if we have a balanced chemical equation, we can have relationships between the quantities of reactants and products. So we call those types of calculations and those types of quantities stoichiometry. And do you remember that I told you that if we have a balanced chemical equation, we can see how many moles of our products react with each other and produce and gives us their products, right? And then we can see how many moles of reactants we have and how many moles of products we have. And also, if we are given specific grams of a reactant, we can find specific grams of the other reactant and also the products. So we can just do calculations and find quantities in chemical reactions. And we call this procedure stoichiometry. So as I just mentioned, stoichiometry allows us to predict the amount of products that form in a chemical reaction based on the amount of reactants. And similarly, it also allows us to predict how much of a specific reactant should we have in order to have a specific amount of product. So I just wrote all of these, and anything that I'm teaching you is just right from your book. But I wrote these down so you know in the exam what questions I can ask you. And as I told you, I'm giving you these definitions so you can just answer more questions in short amount of time and make sure that you answer them right. So if I tell you, if I have this one omitted, and I said this, or I have blank and says allows us to predict the amount of product that form in a chemical reaction based on the amount of reactants. So what would be the answer? So if I ask you this quantity or this concept allows us to predict the amount of product that form in a chemical reaction based on the amount of reactants. And then I give you 4 different options. So which would you choose? Exactly. Or I give you which of the following sentences is not correct. And I say mole allows us to predict the amount of products that form in a chemical reaction based on the amount of reactants. One would be mole, one would be gram, one would be acid-base reactions, you know what I mean? So just if you know the definition well, it doesn't take you much to answer these questions. So based on what I just talked about, can anyone define a stoichiometry for me? Anyone?
The numerical relationship between chemical quantities and a chemical equation.
Exactly. So is this clear? What is a stoichiometry? So this is the basis of chemistry. So like chemical reactions, chemical equations, and how to convert between certain amount of reactants to certain amount of products, so you should know stoichiometry well. And as we mentioned, it also allows us to predict how much of one reactant is required to completely react with another reactant. And this is important that you know that it should completely react. Because as I'm going to teach you, sometimes it happens that we have like extra amount of a reactant, so all of it cannot react. So what stoichiometry gives you is the amount of reactant that is completely reacts or is being consumed to produce or gives you products. Any question about this? Is this clear what is a stoichiometry? Okay. So, okay. Because I know how much you guys love pancakes, we continue talking about pancakes. If you go through your book and then see the worked example, they talk about making pizza, so it has like similar analogy of making pancakes. But since I talked about making pancakes last session, I just continue with that. So do you remember that we said one recipe of making pancakes could be like having 1 cup of flour, 2 eggs, half a teaspoon baking powder, and that gives you 5 pancakes, right? And imagine this is the recipe. So we can write that as a chemical reaction, right? That we have like, just highlight that here for you. So we have like 1 cup of flour plus 2 eggs. You can think of it or look at it as a chemical equation. And imagine you have this recipe, right? And I ask you that I went, through my fridge and just look at the ingredients I have, and I tell you that I have like 3 cups of flour, 10 eggs, and 4 teaspoons baking powder. And I ask you, how many pancakes can I make? Can you tell me how you can know that how many pancakes I can make?
Putting it into an equation.
Yes, so how can I do that?
So you would take the factors
Uh-huh.
of your original equation of 1 cup flour, 2 eggs, whatever,
Uh-huh.
and you would factor it into, you would say, well, if you have 3 cups of flour, that's 3 times the amount of flour.
Uh-huh.
If you have 10 eggs, that's 5 times the amount of eggs.
Yeah.
And then you just factor it in and figure out how much you can make with your least common.
Exactly. So to kind of put that into pictures. Okay. So here I wrote the equation again. So we have like, oops. Should be careful. Okay. So we have like 1 cup of flour plus 2 eggs plus half a teaspoon baking powder gives 5 pancakes. So as your friend said, we have like kind of like similar procedure that we were doing before. Do you remember writing conversion factors? And I told you, if we look at this as a chemical equation, we know for like 1 cup of flour, we get 5 pancakes. For like 2 eggs, we get 5 pancakes, and half a teaspoon baking powder gives us 5 pancakes. So now that I have, maybe I use the pen. If now that I have like 3 cups flour, I write this conversion factor. So for 1 cup, I get 5 pancakes. Now that I have 3, how many do I get? It's like 15. So the same thing with the eggs. If I have like 10 eggs, for like each 2 eggs, I have like 5 pancakes. So in general, I'll be having like 25 pancakes. And the same thing with like baking powder. If I do the calculation, I get like 40 pancakes. So based on these, can anyone tell me with like 3 cups of flour, 10 eggs, and 4 teaspoons baking powder, how many pancakes can I get at the end? 15, exactly, the least amount, right? Because if you tell me that, oh, we can have 40 pancakes, but we don't have enough flour for that, or like eggs for that, right? So the least amount of reactant, or like least amount of my ingredients, defines how many pancakes I'll be having at the end. So we can make only 15 pancakes. So in other words, as I said, the amount of flour we have limits the number of pancakes we can make. So if this very chemical reaction, the flour would be chemical reactants. So in general, if I give you a chemical reaction, and then I ask you to write the chemical equation, balance it, and then remember all the calculations that you do in this chapter is based on a balanced chemical equation, because that is the thing that gives you the moles, and all the stoichiometry and calculation is based on balanced chemical equation. So imagine you have a balanced chemical equation, and I ask you what is the limiting reactant. So what you do is that based on your reactants, you calculate how much of the product you can produce. And the one that gives you the least amount of product would be your limiting reactant, such as this example. So if you forgot what was limiting reactant, imagine and then remember the pancake example, that what you do is that you calculate the number of pancakes in each scenario, and then the one that is the least, gives you the least amount of pancake, is your limiting reactant or limiting ingredient. Is this clear? Okay. So now let me go to the next picture I have here, which is this one. So again, like always, because I'm going to give you definitions in the exam, I also wrote it here, and it's exactly taken from your book, so don't worry about not having any of these definitions. You have them all in your book. So the reactant that limits the amount of your product is called limiting reactant. And as we said, you remember that limiting reactant simply produces the least amount of product. So I kind of highlighted these words here, so you know that what I possibly can ask you in the exam. And as I mentioned in BBLearn, in the announcement, I posted a study guide for your chapter 7. So if you study that, you'll be in good shape for definitions in the exam. And I'm going to do the same for chapter 8 and the next chapters as well. So just ask me if you have any questions anytime about anything, I guess. So now we want to learn about another definition, which is theoretical yield. So in the example that I just gave you about pancakes, if those ingredients and then making pancakes is if we consider that as a chemical reaction, we call 15 pancakes a theoretical yield. So yield is basically your product. And theoretical means it's based on a balanced chemical equation, right? So theoretical yield means the amount of product that can be made based on the limiting reactant. So just recap, if we have different ingredients or different reactants, the one that gives us the least amount of product is our limiting reactant. And the amount of products that limiting reactant gives us is called theoretical yield. So 15 pancakes in this case is our theoretical yield. So is this clear? It's just definitions, right? So now can anyone tell me what is limiting reactant? Okay, nice. So can anyone tell me what is theoretical yield? Anyone?
The amount of product that can be made to the result of a limited.
Exactly. So is this clear? So don't get confused by the names, I mean, limiting reactant is a reactant that limits the reaction, right? So it gives you the least amount of product, and yield is basically your product. And theoretical means that it's just based on a balanced chemical equation, it's based on the theory, right? Is that clear? Any questions so far? Okay. If no questions, I go to the next slide in a sense. So something to consider, so I'm just like, as I said, writing everything that I potentially can ask you in the exam. So we can also call limiting reactant limiting reagent. So if you saw those terms, don't confuse them with each other, like they're like basically the same, don't get confused. So the term limiting reagent, is sometimes used in place of limiting reactant. So I can give you this in the test as like true or false. Is the following statement true or false? The limiting reagent is sometimes called as in replace of chemical limiting reactant, sorry. So limiting reagent is the same as limiting reactant. True or false? Yes. So you see, if you study, these things would be super easy, right? So my aim is to make sure that all of you get good grades. So if you just like follow me and then just like do things that I'm telling you, I guarantee that all of you will do really well in the next exam and your final. So now here, I just like basically the same thing that we talked about. We had like 3 cups of flour, 10 eggs, and 4 teaspoons baking powder. And then one of them basically gave you like 15 pancakes, the other 25, the other 40. So we call this, so 3 cups of flour are limiting reactant, and then 15 pancakes, theoretical yield. So just kind of visualize that to make sure that it is clear. Is it? Okay. So, okay, now we want to talk about actual yield. So imagine we were making pancakes, and then theoretically, based on the ingredients that we had, we could make 15 pancakes. But imagine, you get distracted with your phone or like other obligations, and then you come back to the oven and then see that you accidentally burned 3 of them, right? Or, you're like making them, or you're like putting them on the table, and then you drop 1 of them. So now, although you could have 15 pancakes, but now you don't have 4 of them. So you end up with having 11 pancakes. So this is the same with chemical reactions, that although theoretically, you can have like, based on the chemical equation, you can predict how much of the reactant you would have. In real life, like most of the time, you don't see the amount of products that you should have, and then you see less amount. So we call that actual yield. So in this case, for our pancakes, our actual yield is 11 pancakes, but theoretical yield is 15 pancakes. Is that clear? Any question about theoretical yield or actual yield or limiting reactant? Are we good? So the actual yield is the amount of product actually produced by a chemical reaction. So you remember these definitions well. because I'm going to ask you in the exam whether true or false, or I tell you which of the following statement is not correct, or so you're gonna see these definitions, because if you know them, you can just answer the question so fast and correct. Okay, if no question about this, any questions? Okay, so now we have one more definition as well. So we have, oops, let me have like the blue one. So we have another quantity here, which is like percent yield. So percent yield basically is like your actual yield divided by theoretical yield multiplied by 100%. So your percent yield is the percentage of the theoretical yield that was actually attained. So based on like your theoretical yield, the percentage that is actually attained, we call that percent yield. And in the pancake example, your percent yield is like 11 pancakes divided by 15 pancakes multiplied by 100%. So it's like 73%. So in general, in like chemical equations and chemical reactions, percent yield is actual yield divided by theoretical yield multiplied by 100%. And then the definition is the percentage of the theoretical yield that was actually attained in your chemical reaction. Is this clear? So can anyone tell me what is actual yield?
It's the amount that you actually produce.
Yes. What is limiting reactant? Exactly. Yes. So what is theoretical yield?
The yield that you should be able to produce.
Exactly. And then, or if I ask you, how would we calculate theoretical yield? Can anyone explain that to me? Imagine I ask you that in combustion of methane, and then I give you like some, and basically some quantities. But in general, if you want to calculate theoretical yield, what is the procedure, or what information should I give you? Yes. So basically, if you have like your chemical equation, if you balance it based on that, you can calculate your theoretical yield. So remember, theoretical yield is based on theory, is based on the balanced chemical equation. But your actual yield is based on reaction conditions. So if I tell you that what is the actual yield in making pancakes, so for each individual would be different, right? For instance, because when I make the pancakes, maybe I burn 10 of them, or maybe my oven is broken, right? But for some other person, they can be really, attentive, and then they're a really good chef. So the actual yield depends on chemical reaction and reaction conditions, but theoretical yield is just dependent on the balanced chemical equation. Any question about all of this? Are these clear, these concepts? Okay. Okay, let me now some examples. So consider this reaction. To aluminum in solid phase. And something to remember is to always write the state of reactants and products in your chemical equation, because these are like important information that states will give us. Okay, and if you begin with 0.552 moles of aluminum and 0.887 moles of chlorine, what is the limiting reactant and theoretical yield of aluminum chloride in moles? So can anyone tell me how to solve this problem? So you have like two reactants, one product. You have the balanced chemical equation, and you are given the moles of each of the reactants that going to react with each other, and you want to find what is the limiting reactant and what is the theoretical yield. So do you remember the pancake examples? And then we wanted to see how many pancakes we can make. What did we do?
Like the 0.552 moles of aluminum plus the moles of chlorine equals the 2 moles of that.
Yes. So basically, if you write conversion factors and then based on the balanced chemical equation, you can see the relationship between like aluminum and aluminum chloride, right? You see that based on this, 2 aluminum gives you 2 aluminum chloride, and then 3 chlorine molecule gives you 2 aluminum chloride, right? And then you have like your moles, so you can do calculations with the same rationale that we did for pancakes and find how much or like how many moles of aluminum chloride would be generated in each case. Let me just write that to make more sense of that. So here we want to find how many moles of aluminum chloride equals 0.552 moles of aluminum, right? And then we do the same thing. See how many moles of aluminum chloride equals 0.887 moles of chlorine, right? You want to find each of these reactants, how much of products will give you or is corresponds to, right? And then you write conversion factors. So here you want to omit mole of aluminum and find mole of aluminum chloride, right? Remember, if you want to find limiting reactant, the way is to calculate moles of your products, compare, see each one is least, and that reactant that produced the least amount of product is your limiting reactant. And the amount that it actually produces that specific product would be your theoretical yield, right? So here can anyone gives me this ratio? Yes, 2/2, right? Because here you have like, oops, just switches to. So 2 moles, 2 moles. So this would 2/2. And that would be 0.552 moles of aluminum chloride. Any question writing this? So you are given the moles of your reactant, and you, based on the balanced chemical equation, you know the relationship between the moles of product and moles of your reactant. So you write the corresponding conversion factor and find moles of your product. And you do the same here. So you have like moles of chlorine and moles of aluminum chloride. So can anyone give me this ratio? Exactly. So for 2, so you just go to your balanced chemical equation and just read these numbers and put them here. So these two cancel out, and then this number would be 0.591 moles of aluminum chloride. So comparing these two numbers, can anyone tell me what is your limiting reactant? Yes, why? Exactly. You compare these two numbers and see which one is least. So this one, the reactant that produces the least amount of product would be your limiting reactant. And this number would be your theoretical yield. Is this clear? So when you want to find your theoretical yield and your limiting reactant, what you do is based on the balanced chemical reaction, write a conversion factor that gives you the amount of product. And then you do that for both of your reactants, compare. The amount of product that is the least is smaller, that is your theoretical yield, and the specific, that corresponding reactant that generates the least amount of product would be your limiting reactant, because it limits the reaction, right? If you had like more of that, you could have had like more of the product, right? But you don't, because that reactant limits more production of your product. Any question about this? If you have any question, or like you go through your notes or like read the book and then you encounter any difficulty, I scheduled more office hours for you, as well as after our class. That is, always I have office hours. So just don't hesitate to reach out to me, Even if those times won't work for you, I just schedule more office hours for you. So don't worry about anything. Now, I'm going to give you one homework problem. As I said, so even if you're happy with the grade of your exam 3, as I said, I've added these grades. So even if you got 100, you can get up to 120 or more, depending on how many homework problems I give you. And then when I add your grades at the end, it's like out of 800. So what I'm saying is that it can help your final exam and your exam 4. So even if you think you don't need that, just it doesn't hurt to always get more points to be sure that you get a good grade in the course. So I encourage you to do that, but it's not mandatory, so you won't be losing any points. Anyway, consider this reaction. 2 sodium plus fluorine gives 2 NaF solid. If you begin with 4.8 moles of sodium and 2.6 moles of fluorine, what is the limiting is the okay, I have to do this because low battery doesn't let me to write more. Okay. What is the limiting reactant and theoretical yield of NAF in moles? So can anyone tell me how to solve this problem?
You would do the conversions, and then you would put that in, and then figure out the theoretical yield and the actual yield.
Yes. So you cannot find the actual yield based on this information, but as you all kind of mentioned, so you have like the conversion factors, you can find the amount of products based on each reactant with writing corresponding conversion factors. You compare the numbers, you see which one is like smaller, and then you know the reactant that gives you least amount of product would be your limiting reactant, and the corresponding number would be your theoretical yield. So just like ask me if you have any question about this. So now we talked about like all these things in moles. So as you saw previously, we were doing calculations based on grams. So you can also calculate like your theoretical yield in grams. So that's why here in the problem statement, it would be what is the theoretical yield in moles, because now you have like information based on moles, but it give you grams. You can find theoretical yield in grams, and the procedure is the same as what we were doing in chapter 6 and what we were doing in chapter 7. So that's why I was emphasizing those chapters, emphasizing on those a lot. So here, if I give you grams, how would you convert grams to moles? Anyone? Exactly, molar mass, or like your formula mass, right? So based on your molar, so how would you calculate or like find out molar mass for elements? Yes, you go to your periodic table, right? And then read those numbers for elements. But how would you calculate those for your compounds? Exactly, you see in your compound how many of each atom you have, multiply. So you say number of atoms, or like your first element, multiply by their, atomic mass, or like molar mass, plus, the second element, number of elements, multiply by, for instance, if we had like MgOH2, right? We would say that we have 1 Mg plus 2 oxygen plus 2 hydrogen, and then you go to the periodic table, read the numbers for hydrogen, oxygen, and then magnesium, which is 24.31. And then substitute this here, and then solve the problem, right? So if you know how to do that, here is exactly the same thing. If I give you grams, you just have one more conversion factor. You convert grams to moles by your molar mass, and this one, the number would be gram per mole. It means 1 mole of your compound. What is the grams of that, right? So when you find the moles, the rest would be the same. Just what I just taught you, it would be exactly the same. But your answer, again, you should write another conversion factor to convert moles to grams. So let's do one example of that too. So, I make sure that you know what I'm talking about. So ammonia NH3 can be synthesized by this reaction. So we have like two, is it better? No. 2 NO gas plus 5 hydrogen gas gives 2 NH3 gas plus 2 H2O gas. What maximum amount of ammonia in grams can be synthesized? Yes, I write it. What maximum amount of ammonia in grams can from 45.8 gram of NO and 20.4 gram of H2. Okay, so now it says what maximum amount of ammonia in grams can be synthesized. Can't anyone tell me what is this sentence equivalent to? What's that? Yes, so what is it based on the thing that we just talked about, like limiting reactant, actual yield, theoretical yield, percent yield? What's that? Exactly, because you have the balanced chemical equation, and now we want to see how much of that we can have, right? And then if you just do the calculations, you see that one gives you, the least amount of product. So basically between like NO and H2. So here we want to see what maximum amount of ammonia in grams, so how many grams of ammonia equals 45.8 gram of NO, and how many gram of ammonia equals 12.4 gram of H2. So what you do is that you write a conversion factor converting gram of NO to moles of NO, right? And then moles of NO to moles of NH3 based on the balanced chemical equation, and then moles of NH3 to grams of NH3, right? So these two you do based on your molar mass. So NO, you go to back of your book, N is 14 plus O, oxygen, is like 16, and NH3, we say 14 multiplied by 1 plus 1.01 multiplied by 3. And here I just going to write these numbers for you, so I make sure that I finish this problem. And this one would be 30.01. And this one would be like 2 over 2, because for 2 NO, you have like 2 moles of ammonia, right? And then here for 1 mole of NH3, you have like 17.04. And then when you do the math, you get like 26 gram NH3. And then when you do the same thing for hydrogen, you have like grams of hydrogen to moles of hydrogen, moles of hydrogen to moles of ammonia, moles of ammonia converted to grams of ammonia. Then you write 1, 2.02, and here 2 over 5, because here you have 5 moles of H2 gives you 2 moles of ammonia. And then 1, 17.04. And then when you do the math, you get 41.8 grams of NH3. So comparing these two numbers, I guess, at the beginning, maybe it wasn't obvious that ammonia is, the quantity that your problem statement asks is your theoretical yield, because you weren't sure that, here like NO gives you the least amount of product. But now that we solved the problem, it's obvious that now, NO gives us the least amount of NH3, and that corresponds to our theoretical yield. So this is least amount of product. So now maximum amount of ammonia that can be synthesized in this chemical reaction is this much. It's like the pancake example. Although you have like more eggs or like more, teaspoon baking powder, you cannot make more, right? So the maximum amount of, so don't get confused of like the wording. Although, the limiting reactant is NO and your theoretical yield is 26.0 gram of NH3, this amount is the maximum amount of product that can be produced. Just email me if you have any difficulty in any part or like you have any questions.